Welcome to Timber Development UK's University Design Challenge 2022, Southside Hereford, which is organised in partnership with Edinburgh Napier University, NMITE, which is the New Model Institute for Technology and Engineering, and the Passivhaus Trust. This challenge is for students and 2021 graduates studying built environment subjects at universities across the UK. And this series of webinars running from January to March is set to inform the participants as well as the wider audience of professionals and the industry who are considering using timber in construction. The Southside Hereford University Design Challenge is interdisciplinary, cross-university, and a team challenge to design, engineer, specify and cost a community building from timber to Passivhaus standards. It's a live building, and it will be a live building, about 800 square metres and a budget of 1.6 million. The site for the physical building is on the boundary of two fields and is a greenfield site, formerly park and farmland. I'll pop a link in the chat. We want you to enter by the 11th of February, and we have the TRADA challenge page, we have a YouTube channel, and obviously where you sign up for Eventbrite. And again, we'll put the links in the chat. Tonight's talk is on timber in a sustainable built environment, and we'll hear how we can achieve low carbon construction, protect and enhance biodiversity, and create regenerative timber buildings that can be deconstructed and reused, making them people, planet and climate friendly. Our speakers tonight include Charlie Law, Timber Development UK, Professor Francesco Pomponi from Edinburgh Napier, Jack Dilworth from Plan Design, and Adrian Campbell from Change Buildings. And I'd like to hand over to Charlie Law.
Thank you, Tabitha. Brilliant. Thanks. Welcome, everyone, to this Timber Development UK Design Challenge 2022. It's great to have you all participating in this. It's a really great initiative that we set up probably about 5-6 years ago, and it's gone from strength to strength and got larger and larger, and obviously now culminating in at the moment with these presentations over the next 2 months, which is great. Lots of information that you'll be able to feed into and glean and take on board for your design projects, hopefully. So Tabitha started to set the scene on the sustainability side, and Timber Development UK generally. So Timber Development UK, if you don't know who they are the organisation formed by the merger of the Timber Trade Federation and the Timber Research and Development Association, so to TTF and TRADA. So obviously the University Design Challenge was set up by TRADA originally, and the Timber Trade Federation has been involved in that for the last few years, helping to move the university engagement program forward. So that merger is, for the university engagement program is already set really and has been there for a while. But those two organisations formally came together at the beginning of last year, March last year. Still operate slightly separately, but will be joined together, and you'll see a lot more TD UK branding coming out over the coming months in the middle of the year. So one of the key things that we felt we needed to do more of was on the sustainability side. Originally, we had TRADA and Timber Development UK very much, TD UK really very much looked at responsible sourcing was the key issue that was being looked at by the Timber Trade Federation, for example. And we very really touched on carbon and circular economy as part of the TRADA work. And that's something we really wanted to build on and improve, and that's why I sort of took the role of part-time of the sustainability director for Timber Development UK, and we've set up a sustainability committee which involves a lot of our members, and then that committee, underneath that committee, we've set up a number of subcommittees looking at various key topics, and obviously two main ones we're talking about today is carbon and circular economy, and Adrian is actually on our circular economy subcommittee, which is great, and great to have him on there, and also responsible sourcing. So three key work streams that we're going to be looking at over the years for Timber Development UK. So on circular economy, looking at things like single-use packaging for our trade side, but very much looking at European funding on with our sort of partner organisation CEI Bois on reuse of existing structural timber elements, including manufacture of CLT and glulam from recovered timbers, things like MDF recycling, as well as case studies on service life, flexibility, reusability, and resource efficiency, which I know Adrian's going to be talking a lot more about later on. On the carbon side, you may have seen our life cycle assessment paper, which looks at how you do life cycle assessments for buildings as well as products, and that will also be developing the net zero carbon roadmap for the timber industry. And obviously we've got this target of obviously net zero by 2050. We're in a climate emergency, so that is a really important piece of work, and that sort of very much ties in with the LCA paper that we're doing, along with environmental product declarations for products. And then the last bit was very much around responsible sourcing. So obviously the continue the work of the old TTF Forest Forever Committee, looking at responsible sourcing, but also include updates on what we call our responsible purchasing policy, to include things on carbon, OPSS work on legality and due diligence, and FLEGT, which is a licensing scheme for certain timbers, but also incorporate within that things like the Code for Construction Product Information, CCPI, which is making sure that the products that are specified actually do what they say they do on the tin. So I think that's enough from me. A bit of scene setting there. Really looking forward to these presentations tonight, and I'll hand you back over to Tabitha to introduce our speakers. Thanks, Tabitha.
Thanks, Charlie. I'm going to defer to our speakers to introduce themselves. It's always a lot quicker. Sorry, Francesco, if you'd like to share screen. It's the first time we've met. So introduce yourself to the audience.
I will. I got a slide for that, actually. So thanks for inviting me, and honored to be here, really. So Charlie was using a lot of very important words: net zero, climate emergency, pledges, commitment. My role in this very complex space that will ensure we transition to a sustainable built environment is to help measuring out our progress in what we do. So that's the whole idea of my talk tonight. Introducing what generally takes a full module at a university in 30 minutes. I'll do my very best. And it's about the role of embodied and whole life carbon assessments. Now, talking about introducing me, I thought I'll dedicate a slide just to make sure you think there's some credibility attached to my name. I've been working in the space for about a decade now. I'm based in Edinburgh at Edinburgh Napier University. I was in Cambridge before, and I retain an affiliation with the University of Cambridge, the Institute for Sustainability Leadership. Lots of things I'm doing in the country and outside the country. Something new which might interest people in this webinar is the Whole Life Carbon Network. There's a voluntary group of professionals. We just put a LinkedIn page up, and there's a website going up. And the idea is just to create a hub for knowledge sharing. Professionals, academics, practitioners, local authorities, there's pretty much everyone in there. And there's a Google group where people just ask questions. There's a lot of willingness to help, some heated debates at times, but it's all good because we're in this together. For people who are familiar already with this space, the RICS professional statement, which came out in 2017 for whole life carbon assessments in the built environment, that's something I contributed to. And then there was a couple of years ago, I think mid-2020, the embodied carbon roadmap for Scotland. I should have said, I forgot to mention it, one of my kids tested positive for COVID like 7 minutes ago, something like that. So I'll stay for the full duration of my talk. I might need to dash to figure out how to live tomorrow. But you're welcome to hit me on LinkedIn and talk to me, or ask for my contact details. There's my email in the last slide. I'm really happy to talk about this all the time. Before we talk about carbon, I thought it was useful to do a couple of caveats. First one is climate change is, of course, big problem. There's an even bigger one behind it, and that's the biodiversity crisis. And it's something that is going to be touched upon tonight, which is great. The reason why it is important is because governments and commitments and people in the profession and the standards that we're seeing are all about carbon at the moment, because greenhouse gas emissions go to the atmosphere to warm the planet, and a warmer planet incurs climate change, which is what we want to avoid, and that's great. But it's not as simple. There are other things, not just on the environmental side, also on the social side. And it's important we remain vigilant on all the others and avoid this carbon tunnel vision. Now, caveats done, I'm happy to talk about carbon, knowing that you all know it's not the only thing that matters. If anyone is in doubt as to why we really need to put buildings and construction at the heart of the sustainability transition, is because they are the thing that matters the most. So Ban Ki-moon, who's the 8th UN Secretary General, put it very, very clearly. The global struggle for sustainability will be either won or lost in cities. And that's because buildings and construction they're top contributor for all the key things that matter at the moment. And that's resource extraction, waste generation, the emissions that worry us a lot, and global energy demand. So by working on our buildings and cities, both existing ones, as well as the newly planned and those that will be built within this century, there's a lot of good that we can do to the climate crisis. Now, surprisingly, if you think about building regulations in this country, for instance, they've been around for decades. And we've been worried, European level, but generally in the Western world, a lot about what happens to the buildings when we are in them. Maybe it is quite logical, because that's when we experience the building. So we've been worrying about energy demand, about insulation, air tightness, comfort, and that's great. But then at some point, we realized actually buildings do not just happen to exist. They get built, and at some point they're no longer useful, or we think they're no longer useful, and therefore we knock them down. So it was important to structure the life cycle of a building in a way that captures everything that happens, and not just the use phase, which is what is currently only regulated in this country. So if you want to build a very poor building from an energy efficiency perspective, then there will be regulations that, in theory, prevent you from doing so. If you want to build the buildings that is very poor on the carbon side in terms of embodied carbon, at the moment you can. The good thing is that 11 years ago, there was a standard coming out of the European Union that started slicing the life cycle of the building into different stages. Maybe you're all familiar with this, or maybe not, but I'll still spend a couple of minutes introducing this. So we decided that we would call as A, the pre-use phase. So everything that happens from sourcing the raw materials to finishing the construction of the building. And then the B stage is the use phase, which extends hopefully for decades, although the life expectancy of a building, a non-domestic building in central London at the moment is about 20 years, and that's really sad. And then the end of life, so when we decide to knock things down because they're no longer useful. There is something that I'm sure it's going to be touched upon probably by Adrian in terms of circular economy, and that's the module D, which is everything that happens beyond the life cycle of a building. And it's very, very important. 10 years later, in the UK, we thought it was time to clarify terminologies, because we couldn't agree on what to call things. So there is this nice publication by Letty, and if you don't know what Letty is, just hit letty.london. It's a great network and really worth following what they do. Just amazing. The RIBA and the whole life carbon network I mentioned at the beginning. So just to put the terminology clear, we decided that embodied carbon was a bit confusing because it involves both things that happen before a building is occupied and then after it has been occupied. So things that are happening now that we can control to an extent, and things that might happen in the future that we have really poor visibility on. So we decided to focus on the upfront carbon as a terminology captures what's happening in the here and now, so the product and construction stage. Then the embodied carbon plus the operational carbon make up the whole life carbon. Module D stays out, and you can see is really focused on the circular economy to ensure that we don't mix things that might happen in the future with impacts that are happening now. There's still a lot of debate, and there's even subcommittees discussing Module D. I generally take one of my child when there's subcommittee meetings, because that's sort of level of conversation that they can handle. Now, after this introduction, if you think about this simple question, let's say we're able to do 0 carbon buildings in operation, then 100% of the whole life carbon of a building like this is going to be embodied. And that's why embodied carbon matters so much within a whole life carbon perspective. Because if we keep making progress, as we have been doing, in basically eliminating the carbon emissions linked to the operational phase. And if you think about Passivhaus, for instance, that's a good example where, in theory, you can achieve a carbon-free home while you're in it. So there will be energy going around, but it's coming from renewables, very little of it. So it's not incurring carbon emissions, which is great. But this implies there's a lot of embodied carbon right now that we need to focus on, and we're not focusing on because there's no regulations in place for it. Though there is Part Z, that's a proposal amendment to building regulations discussed in Parliament tomorrow morning for 10 minutes. Now, just to explain why this is crucial, I would like to draw your attention on this case. So there are 2 cases where decisions are obvious because, maybe something benefits the embodied carbon, the operational carbon, no brain. But there are few cases, and this is important in a design challenge because I think you need to think about the consequences of your design choices in both the short as well as the long term. Let's say you have a regular wall insulation, so it's A, and it's got a certain embodied carbon. Then you have a thicker wall insulation, which is going to perform better, that incurs more embodied carbon, and that's the product B. Now, this causes an embodied carbon premium to start with. So at year 0, when you finish construction, you have this premium that you've chosen to incur to put a better product in your building, and that's great. Now, that better product is going to perform better than the alternative year by year for a long time. And then at some point, it will repay its embodied carbon premium. So we need to think about embodied and operational as 2 sides of the same coin. Sometimes they work in harmony, other times they work in contrast. And it's important we are aware of the relationship they have so that if they work in contrast, we can figure out the trade-off. For instance, if a product takes 20 years to repay its embodied carbon premium, then in 20 years, the UK grid is very likely heavily decarbonized. So I'm not sure it's worthwhile right now incurring that embodied carbon premium on a dirty grid to save or to break even only in the future on a much, much cleaner grid. Now, if we go back to timber, which is what we're all here about, I think trying to put the scientist hat on, that we should be aware of strengths and weaknesses so that we can make the most of it, because it's a great material. So timber is low carbon. And by low carbon, I mean that the processing and products and manufacturing behind timber incur fewer carbon emissions than its alternatives. And that's a fact. So timber is better than the alternatives because it incurs fewer carbon emissions. Now, timber is also bio-based, and that's another great news because when trees, general biomass grows, through photosynthesis, they sequester carbon and use it to grow. Timber is also naturally grown. Now, I'm sure if someone manages a commercial forestry, will tell me, hey, don't think you just plant the trees, bugger off for 30 years and back and harvest. That's not what happens. Surely there is a lot of inputs and care and activities, but I'm pretty sure that it's not as much as quarrying or mining iron ore and transporting it into global supply chains and firing kilns of 1500. degrees Celsius. So we have a lot of help from nature in giving us this amazing material that we can use to build our buildings and cities. On the other side of things, it's important to also be aware that timber is not infinite. So unfortunately, we didn't plan 30, 40, 50 years ago to accommodate the global population that we will have on the planet. So we don't have right now enough timber to just switch to timber construction instantaneously. So we need to ensure that we use the trees that we have and the timber we have in the best possible way. And then we plant as aggressively as we can without harming biodiversity, so that there will be more timber available in the future. A sad element, truly sad. I was at the recycling center over the weekend. And if you see a lot of construction timber, if you go one of the recycling centers in Edinburgh, for instance, loads of construction vans, small firms, taking the timber that's coming out of small refurbishment products, will go into the timber skip. And yeah, it does power Scotland in the sense that we're not burning fossil fuels, but we're still burning timber. There surely is a better fate than that for timber. And I think it's fundamental that people in the supply chain are also thinking about the end of life and how to divert that timber from being burned. Because if we do burn timber, since we're not doing incineration with carbon capture, what happens is that the wonderful carbon that the trees sequestered and stored for years is going back to the atmosphere. So we're back to square zero. And the other thing is that timber cannot be suitable for all the projects. So I'm saying this not because I disagree with pushing the limits. I think it's great that we keep pushing the limits and building even taller buildings out of timber, testing every possible technological domain in which it can be applied. But meanwhile, I see a lot of discussion. I'm in a committee for the Regenerative new building regulations, and there's a lot of heated debate around, oh, yes, you can do this with timber. And then the concrete people say, oh, no, you can't do this with timber. And it feels as it's stalling progress just to make the point. So if we accept that, okay, we can do 98% of things with timber, that's great. Think about this design challenge, but also thinking about potentially informing some calculations in industry. This is a paper that we've been working on because we wanted to prove beyond doubt that timber wins. So the way we did it, and the badge that you see there is a gold data standard badge awarded by the International Society for Industrial Ecology, saying that basically every single piece of data, it's in the paper or it's supplementary material. So it's open science at its best, and you can find whatever you want in the supplementary information attached to this paper. So to prove our point, what we did was, because previous comparisons were working at either a building element or on mass basis, and this is not useful as a functional unit because you don't use the same amount of timber and steel in the building, and a timber beam is very different from a steel beam. So what's the point of comparing the structural elements? So we thought we'll go in with the full building design. So what we did is we generated a frame geometry for a specific case. So with a certain number of stories, certain loading required. Then we engineered that specific frame geometry into 3 different variants. So one out of reinforced concrete, the other one is a steel frame, and then an engineered timber. And we've done this for well over 100 different buildings in order to build a population of geometries. We've then applied some uncertainty analysis in order to capture the variability of supply chains behind each material to ensure that we wouldn't use just a single number. Maybe people in this room in the UK are familiar with the IC database. So that's the UK data set, which is great. It captures some values that will have been true at a certain moment in time in a supply chain. But by using this uncertainty analysis, we could go broader and ensure that we stress tested the values that we regularly use to see, okay, what if this material is coming from further afield? Will a longer transportation change its sustainability proposition or not? And from the graph labeled with an A, and that's about structural masses, so material intensities, timber is the red one, you can see that timber wins hands down. So timber structures are much, much lighter. And that's good because there's less resources being used. It's also good because less stuff is being moved around. So there are savings on transportation emissions. And it's also good because very likely the foundations will be lighter. So it trickles down benefit of a lighter structure, quite literally. And then on the B figure, so the graph below, you can see instead this whole life carbon assessments. Now, even there, you can quite clearly be convinced that timber wins. Some people that have seen this graph told me, hey, yes, but there is overlap between the three curves. So in theory, there are structures where timber would be outperformed by the other materials. Then I had to point out that the left hand of the red tail doesn't overlap with the left hand of the blue and the green tails. Now, this means that the only overlap exists if a very or a poorly designed timber structure is compared with a super efficiently designed steel structure, and not a fair comparison. So if you want to compare these three curves, you should compare like left-hand side of a curve with left-hand side of a curve, or right-hand side with right-hand side. So again, we see that timber wins hands down. One thing that I want to point, quite important and dear to me, is no negative numbers on the x-axis. So you see it starts from 0. And these to prove that we don't need to get into the argument of biogenic carbon, which I think does more harm than good, because timber is great regardless. And the standards are not allowing us at the moment to report on negative numbers. So if we do so, we're just attracting more criticism on a material that is just great. To explain why the numbers shouldn't be negative, I also thought it was great to capture the temporal element of the climate impact. And that's where bio-based materials really win. Now, the blue curve is timber, let's say. So you can see that it starts positive and it goes up. The reason why it goes up, because you disturb the soil a little bit when you're doing plantation at scale, and there is a lot of carbon stored in the soil, so it's likely that some of that carbon will go to the atmosphere. Then trees are in the ground, they grow, and as they grow, they suck carbon out of the air, and therefore we go below the axis, we go into the negative space. Now, when you harvest, again, there is a little increase because you're disturbing the soil again. And then the A2, A5 slice of the figure, that's when we're actually manufacturing and transporting and erecting stuff. So of course it goes up. Nothing happens noteworthy during the useful life of a bio-based product. It's, well, timber products, it's there, it's not sucking up carbon, it's a dead tree. And then we get into this end of life stage. And there's two lines there. So the first one is the one that stays below the horizontal axis. And that could be, for instance, a managed landfill site. So if we can't really find any better used timber and we landfill a timber product, then the carbon is being permanently stored if it's a managed landfill site, because any leakage is going to be captured and the carbon doesn't go back to the atmosphere. If we burn it instead, then we go above. And that's why the standards are not allowing us to report the negative numbers, because it's very hard to predict what's going to happen in 50 years down the line. There is no certainty. So just to be on the precautionary side of things, we assume that that timber will go out again of the system. Very different story, the one above, the yellow line, and that's concrete. So concrete never goes below. Whoever tells you that concrete is carbon negative, as you know, they have a very, very poor understanding of this space. Concrete just goes up and up. Now there's two moments where it goes down. The first one is there just to ensure the concrete enthusiasts will not shoot at me, and it's the carbonation while it's in use. Okay. Now this happens very, very slowly if concrete is exposed to ambient air, and it depends on the surface to volume ratio that the concrete element in a building is exposed to. So if you're actually covering your concrete element in plasterboard, there's no exposure to ambient air, so the carbonation, it's not happening or happening minimally. And then the other moment in which concrete goes down a little bit, it's at the end of life, because there is an idea that concrete will be broken down and scattered in the site after the building is demolished, and then scatter some more so that you can fully carbonate. I'm yet to see this. I was in a meeting with base, and concrete people were saying, well, we'll spread concrete around the country. I was like, I'm not sure. I'm excited about it for carbonation. So it's important to understand that one material has no chance of having climate benefits. It's always on the positive side. The other material surely creates climate benefits, and it's down to us to determine how permanent the climate benefit is, depending on what we do with it at the end of life. Some colleagues at Bath did a similar study. They were also looking at a simpler single structure in 3 different configurations. And you can see again that the minute we factor in the time element, there's no doubt that concrete and steel are up and high, and they stay up and high. With timber, it all depends, again, on what happens at the end of life. Now, cheeky bit here is that they consider the option, and I think just to be on the safe side, perhaps, of no replanting. And if we see that we're not replanting, then timber is not really that great. So it's really, really important that timber is understood within the wider context it exists, not just as a material or as a mass of building product, but as something that was a living element that we thought was good for our uses as a species, and then we must replace it with another living element so that the great circle can carry on. Now, none of this is still being used in practice, the dynamic LCA approach, so this idea of including temporal elements, or very, very few people are using it, just to give credit to those you are. But we should, because otherwise, if we flatten all the numbers into today's time, it's much, much harder to capture the very different curves that we would see when we take the time into consideration. So a few points to take home from me, trying to be quick. Timber wins. It's better than its alternatives. And there is really no reason to go into mathematical creativity and produce these negative figures that make real no sense, because they violate first principles. It's as if we build the building and we kind of undid all the first principles in terms of energy and stuff like that. It's impossible. So let's leave the numbers out and let's follow the standards. The best moment to do whole life carbon assessments, even if they're time consuming, is as early as possible in the design stage. So there is this tendency at the moment that we design a building as best we can, thinking that we know everything about it, and then we kind of engineer it further. Then at some point when we have all the material quantities, we do a life cycle assessment and we get a figure for the whole life carbon impacts of our buildings. At that time, very likely some design choices have been made and carbon lock-ins have already happened. Carbon lock-ins is when you, for instance, you're going to use concrete instead of timber, and you're not going to go back to revise the choice of the structural material. Whereas if we keep a lean approach to this whole life carbon assessments early in the design stage, then we can test out different strategies. What I said, I was focusing on timber, but it's actually true in the wider spectrum of bio-based materials. And if we think about where we are geographically in the global north, of course, we will be building new buildings, but it's a fraction of the challenge. The bigger challenge is refurbishing the existing building stock that we have. And for that, for instance, hemp and straw, they're great materials with fast rotational cycles that we can harvest and replant, and they're great to replace fossil fuel-based insulation products. And lastly, this idea of dynamic LCA, so the temporal elements. I was asked to finish off with some resources. So some of the papers that I mentioned, the standards and consistency project, the colleagues at Bath who published the paper I've shown you also did a great spreadsheet to do this dynamic LCA. It feels a bit complicated at first, but there's guidance and you can go through it. And a wonderful person in the country called Jane Anderson, she's an incredible expert in EPD. I don't have words for her. She also does an annual update on the state global status of EPD. So I put a couple of links there. The ICE-Track-T also released a structural carbon tool in order to quickly evaluate the whole life carbon impacts of building structures. And that's what I have. You can hit me on LinkedIn or email me. I'll state as burning questions. I know we're not doing questions now. So if there is a burning question, I can stay. If not, I'll go and see my child.
Thank you so much, Francesco. That was absolutely fabulous. There are a couple of questions in the chat. You've given so much information there that people are like, oh, that's it. I will let you hopefully answer them and then shoot off to your family. I'm sure there'll be, and thank you for the resources. Jack Dilworth, can you start sharing screen? And I'd like to hand over to you to introduce biodiversity, which one of our participants was very happy to hear.
Yeah, I did notice, but sorry to disappoint. But what I will say is I'm a landscape architect, and I'm sort of co-founder of Plan Design, and we are a design-focused practice. So therefore, we are in the field of making places. We don't specialize, but we rely on lots of specialists to help inform our design, and we work in big teams of, just like the students who will be undertaking this task. We're working in teams across lots of professions. We work in lots of different sectors: education, residential, parks, resorts, transport, all sorts. So how can we protect and enhance biodiversity when building? It's really not for one person or particularly one profession to give an answer to this, but what is valuable perhaps is to explore the question and try and come up with some things to think about whilst you are away coming up with your designs for this competition.
Can I stop you there a minute, Jack? Now, you're not currently sharing your screen.
Thank you very much. I will try that again. There we go.
Perfect.
Now, as I mentioned, I'm a design-based landscape architect. Therefore, warning, gross simplifications and one-sided arguments within. It's a hugely complex area, and that's why I feel it's better to explore the question. So how can we protect and enhance biodiversity through development? We really need to think about the pressures, and some are very obvious. There is a demand for space. Our population is growing, and we simply need space. Now, that taking up space with development has in the past used a lot of resources, but also space is required for all the waste that is generated through construction, and a lot of that waste is not recyclable. We create hard environments, perhaps for efficiency, robustness, tried and tested traditional methods, established principles that haven't been challenged. We adapt the environment to suit our needs, which leads to certain things like light pollution. But perhaps less obvious is how we build and what effect that has on the environment. Even if we plant more trees afterwards, we really have a huge impact on the environment that has taken perhaps decades, hundreds of years to actually establish. And what we find is that there is a lack of understanding of soil structure, for example. So if you level a site to build a huge area for housing, and then you replace that with new soil, perhaps imported, you've actually lost decades of structure in the environment, which we don't fully understand. Lots more pressures. There's also all the supporting land uses that support development that can have a huge impact on biodiversity. There's the physical elements, such as infrastructure, but also the experiential, such as air quality and noise, which can have, again, less obvious impacts on wildlife and biodiversity. And as others have touched on and will touch on, there's obviously the manufacturing techniques of construction materials, which does have a huge impact on climate change, which then has a knock-on impact on biodiversity. So in an ideal world, sustainability would encompass an equal measure of considerations, and we would develop in a holistic manner. And this is a simple diagram, but typically you'd hope for environment, economic considerations and social considerations to have equal consideration. But what is often the case, and what has been the case, is that one of these might take precedent over the others, and that will cause an imbalance. And what's the result? Habitat fragmentation, which reduces effectiveness of habitat. Some species need large areas to roam, but others need continuity to help establish a network of vegetation. General habitat loss, toxic environments, conflict. So where habitat is lost, wildlife can be forced into unsafe spaces, and it can be forced to have conflict with humans. And usually wildlife will come off negatively, but some places of the world, humans might too. And a loss of habitat can lead to a loss of food source. Biodiversity needs to be considered thinking about habitat and food source. They need to go hand in hand, and that goes through to development. How can we reintroduce both? If food source is low, then wildlife will be forced to forage further afield and enter environments that are unsafe and can't support life. But why have we gone down this road, and why do we build this way? There's a sort of an idea that's building momentum that's becoming more and more popular. And it goes back to our early cultures. And this may not be true, but it's certainly gathering momentum. If you listen to Radio 4, this idea comes on quite a lot, where there's the idea that in the good old days, humans lived as part of nature, and we were at the whim of environmental pressures. So therefore we adapted to suit. And a lot of early human art actually referenced nature rather than humans themselves. And that's evident in lots of cave paintings. And at some point we invented farming. And more now, there's an idea that a lot of things started going awry, not just environmental, not just biodiversity, but also culturally. And lots of knock-on effects into our social structures today. And it sort of perhaps got to a point where we decided that our mastery over the landscape for our own needs has led to this idea where perhaps we are masters of nature and we are separate from nature. Now, I think we're sort of realizing the consequences of that now. And we've built environments that suit our needs and not the needs of ecosystems as a whole, of which we don't see ourselves as part, or at least we've sort of gone down this route of not seeing ourselves as a part of. Where does it go? If we keep building for our comfort, what do we end up in? We just stare at our phones in our nice little insulated homes. And what's the future? The metaverse is sort of being bandied around. Do we just enter a virtual world where nothing's real? I'm sure the wildlife of the world would appreciate that, or any people that can't afford these luxuries and have to live with the reality of what we've done to the environment. Anyway, back to something that's a little more serious. We can insulate ourselves from nature, but the environmental pressures that we've always had don't go anywhere. They just build up around the edges. And that's where the collateral damage happens. It happens to the environment. It happens to people that don't have the luxury of insulating themselves from the environment. And these pressures build and build until something gives. And not only is the environment and biodiversity suffering, not only do people from around the world who are less advantaged suffer, but it overflows, and we will suffer in the sort of affluent Western world. There is a biodiversity crisis. More than 70% of ice-free land is now under human control and increasingly degraded. The mass of human-made infrastructure exceeds all biomass. Humans and domesticated animals make up more than 90% of the mammalian mass on the planet, and our actions threaten about 1 million species, 1 in 8 with extinction. These aren't my facts. These are the New Scientist has released a series of articles last year that are really good at just summarizing the position that we're in, and they use lots of nice diagrams that really hammer home the point. And in 2021, we must be the year to reconcile humanity with nature, and that's Antonio Guterres, UN Secretary General. We need to insert ourselves back in nature. So what can we do about it? There are lots of nuts and bolts things we can do. We do understand a lot of those, but I think fundamentally it's about we need to want to do something about it. We need to recognize our role in nature. We need to improve our understanding of ecosystems and how we fit within those. We need to encourage education based on our understanding, but also make research accessible, make it part of our daily lives. We need to be inspired, look at nature and see how problems are solved and nature adapts to environmental pressures. And within that, there's a remarkable world that we are sort of uncovering that is totally inspiring, especially in the world of, relating to architecture and development. Diversify our knowledge base, learn about new materials, learn about processes in nature, how they could marry together to disrupt our reliance on sort of status quo. Look to nature to solve human problems. We have problems like air quality, low air quality, need for space, stormwater management. All of these problems are present in nature, and so are the solutions. As I've mentioned, nature is complex and we are in the infancy of our understanding. Therefore, it's very difficult to come up with a hard and fast answer, and there isn't one. But we can't leave it to one group of people or one profession to solve the problem. And in our world, we're talking about development. And this very much looks like an architect trying to explain something to an engineer. But we should understand each other's role and contribution and share a vision, because you're working in teams across disciplines. And a lot of the major problems are down to a lack of communication and a lack of respect and understanding of each other's skill sets. The problems are so complex that we need coordinated solutions. Engage specialists. As designers, we're often generalists, but specialists such as ecologists, arboriculturists, hydrologists, among others, they uncover opportunities that can give a project purpose and direction beyond the immediate human need. Gather an evidence base around which to build a strategy. Evidence is key. Challenge the brief. A client will come to you with a series of requirements, but they're not necessarily going to be an expert. And they're looking for us as professionals to advise based on experience and expertise. Challenge policy. Policy can be a very top-down approach, not always, but it can be. And in our experience, projects have been far more successful when you unpick policy just to refresh ideas, because it might be out of date, it might be out of touch with people that live somewhere, and those people really need to be brought on the journey. Engage communities and culture. You can design a place by looking at all the physical elements, but as soon as somebody asks you a question, tell me about the people of somewhere, Hereford in this case. I live in Hereford, by the way. Suddenly you can be lost because you've designed to all these environmental sort of considerations. But where's the human continuity? Sometimes small stories from the local community can really enliven a design. As I mentioned at the beginning, we're in the industry of making places, not making things. And to make a place, you need to consider all these things. And it can really bring a bit of magic to a project if you find a few local people that really know the place and have lived there all their lives, perhaps. Hereford is that kind of place. It has a population that live here a long time. It's not a transient population. So in this case, for this project, it's worth getting under the skin a little bit. Understand the existing natural fabric of a place. Look at the green infrastructure, look at the physical elements, look at flora and fauna and cultural elements. These typically stack up in layers because they have evolved over a long time. Nothing has just landed like a spaceship. And we've worked on many projects where a building might be proposed or scheme might be proposed where it lands like a spaceship. And it really can, throw things out of whack. And really things need to evolve from the ground up and bring everything with it, whether it's natural, human, cultural, social. Identify opportunities for development that fit within the natural environment and create opportunities to repair the natural fabric. So once you've built that understanding of the physical properties and the cultural properties and the biodiverse properties of a place, see how an intervention of development can actually start to repair the fabric of somewhere. As I mentioned earlier, it's not just about connecting up habitats and delivering habitat. It has to be hand in hand with food source and probably lots of other considerations. But food source gives incentive and it allows wildlife to thrive. And it creates a rich tapestry, of biodiversity. And there are lots of opportunities within development to do this. It's not all about creating an object. It's about layers of improvement. Once these layers build, before you know it, you've got a design. You haven't had to hit your head against a wall trying to come up with a concept or come up with something that looked great or was impressive. Once you layer up all these considerations, suddenly the design becomes easy. All of your design choices are justified because they will be challenged throughout the process. And the process becomes inherently satisfying. So whenever, which all designers do, we reach the point where we just can't think of anything, that kind of starts to go away if you just go back to your research, back to your evidence base and build the layers back up again. And that really makes the job worth it. And not just that build up those layers in a strategic sense, but it goes all the way down to the detail. This is actually one of our early projects, which is a paragraph 80 house, where the client really wanted to actually have the house immersed in the landscape and have it of the landscape. So all the material choices were informed by the local character and the small details, as well as the wider landscape. Often it will feel like an uphill battle. Those pressures still exist. Economic pressure is a big one, but have these big ideas in your head because you'll end up making small decisions which actually go a long way. And who knows what will become, sorry to use the term, the new normal. Thank you.
Thank you so much, Jack. And thank you for joining us again. I forgot to say at the beginning, so we first met you on the TRADA challenge down in Cardiff just before COVID started. Yeah.
Long time ago, it feels.
It feels like an eon ago, doesn't it? Thank you so much. There's one question in the chat. I wouldn't mind, if you take a look and see if you can answer it. And can I hand over to Adrian, please? who we're also welcoming back. Adrian, you're currently on mute and to share screen.
I did the share screening okay last time.
Always happens.
Was there a question? Oh, there we go.
Right, hopefully you can see that.
Yeah, all good.
Good evening, everybody. Thanks to TDUK and Tab for inviting me along. Just to set the story straight, I'm a structural engineer. I'm not necessarily a sustainability specialist, not a carbon specialist. I'm an engineer who explores these things because I think it's really important for my work in doing projects. So I spend a lot of time thinking about this, but I try to spend more of my time actually implementing it on projects. So I'm really glad for the opportunity to talk to you about it. And hopefully you've been hit with a lot of big issues already. And I'm not going to say, I'm just going to follow back up about some of the similar issues. So they've been teed up very nicely for me. But hopefully at the end, I'll be able to talk about how some of this is applied into projects that we're doing as part of the Positive Collective, who are a group of mates who I work with, looking at regenerative systems approaches, not just sustainable ones. And I'll explain a little bit more about what that means. So everybody has said so far, and it's absolutely true, that we face multiple interconnected crises, not just a climate one. So as Francis said, Jack said, look, the climate emergency is really important, but we have a biodiversity crisis, we've got a poverty crisis, we've got a health crisis. We need to think about these as interconnected crises and actually look at ways of dealing with that. And I suppose the way that I like to think of that is from a systems point of view, and this is well documented by many academics and thinkers around levels of systems intervention which are most effective. Donella Meadows being great. But this diagram, which I found online recently, quite neatly summarizes a whole series of different interventional thinking and orders of change. And what we really need to be doing, if we are going to make a meaningful impact on these crises, is not just deal with events and react to them, which is what we seem to be doing at the moment quite a lot, and also trying to suppress denialism or actually avoidance, this willful blindness towards addressing the crises. That is part of a lot of the discourse, and actually look for the systemic ways of dealing with this, which is going to lead to transformational change within our industry and in our lives. And that means having to deal with bigger thinking issues than just measurement and metrics, which is quite often the dominant things of what you learn at universities, about metrics and reductionism, not actually systems and connections and our purpose as building professionals. So let's think about that. Apologies here to Jack. I think what's really evident to me is that this model of interconnected, the Venn diagram of sustainable development, and somehow sustainability is the bullseye in the middle, I don't think works. I found it really difficult to apply this into project work as an engineer. So I don't use it. I actually banned it on projects I was leading in my previous consultancy, because I think what's been noted by Jack is that we have this very anthropocentric view that somehow economic development can buy our way out of the environmental limits that we're suffering. So we need to look for a different way of conceptualizing sustainable development overall, with a better understanding of the limits that we face, both in, if you call it the Anthropocene, call it the sixth mass extinction event that we're all part of at the moment. So this is a slightly better model, I think, a Russian doll stacked model or nested model, showing that we really need to think that we have known and absolute environmental limits that we need to work within. that we have community systems which actually sit within those environments. And, you know, the words that have been used about localism and finding community-based solutions for projects is really important. And then we have the needs of users fitting within those as another system. And I suppose you might recognize over the last 2 years how much people have actually wanted to connect back into nature as a need for themselves personally and for need for community. So I think we should be expanding this idea of the user into those broader things, but as a subsystem of environment and community overall. And then if we think of buildings as, again, as a subsystem of this, they fit within those limits and they share their values into the community, but within the environment. And we can think of the economic model as similarly as a subsystem within that as well. And the interesting area of dialogue at the moment is how people are looking for different models for the economy to actually bring in the natural value, bring in social value, work within the environmental limits to actually value those much more explicitly than we have in the past. So we need to have a new model for sustainable development, thinking about the environment, community, and these subsystems of our work more clearly. I'm going to talk about the circular economy as perhaps one of these ways of rethinking kind of economic models. And the single takeaway is that we move from this linear take, make, waste approach to one which is more about making, using, and returning that to maintain and value in materials throughout their life and past their first use into multiple uses, to limit impacts, limit resource depletion, and make the most use of valuable resources that we have. Now, although there are very popular definitions, I think for most of these things, we need to recognize that there are multiple schools of thought at play here. And many of these have been around for a long, long time and been within the industry and being used to influence the way that people think about projects in multiple ways. So there are no single definitions for this, in my view, and you need to come to your own view about what you think and understand by these ideas, not just take accepted viewpoints for yourself. So I would encourage you to read as much as you can from multiple sources to come to your own understanding of what these things are and how you apply that into your work. So biomimicry has come up, really, but you know, Jack was just showing that. Cradle to Cradle is a really influential book by Braungart and McDonough. Natural capitalism and this idea of regenerative systems development, which I'll come on to later. So many schools of thought. One of the most popular, though, is popularized through the Ellen MacArthur Foundation, and this was a simplified model of their butterfly diagram that came out of Cradle to Cradle, looking at technical nutrients, which is kind of metals and alloys and their processes, and biological ones, which is all kind of bio-based materials, and what we can do to circulate those by repairing, reusing, refurbishing, recycle, or actually regenerating systems overall back into natural systems. So we have these simple butterfly type representations of a circular economy, but trying to find ways to actually apply that into projects is slightly more of a difficult issue. So that was one field of it, but one of the other very influential schools of thought within this was by Starhall, where he talked about product life extension through one of his pieces of early work. And I think these two models we could think of in slightly different ways about how they represent our work and how they represent work through different life stages of projects as well, and the value chain that is relevant into the built environment rather than other goods and services overall. So what I did as a part of this research, and you can find the paper, I think I've linked it on one of the slides that you'll get a copy of. I wrote a paper a number of years ago now called Mass Timber in the Circular Economy, where I tried to think about, well, how does this apply to the construction industry? What did I think? So I came up with a slightly different but simplified model, which I thought was more in keeping with some of the typical terminology that we use in the built environment rather than fast-moving products. So I came up with this model, which is heavily influenced by Starhull, thinking about making, using and reusing components. But the other thing that struck me at that time was actually we weren't thinking about, well, what do we do about improving things, not just keeping them in this, at stasis, is what seems to be, was part of the terminology around the circular economy at that time. And that's slightly changed now. I think the Ellen MacArthur Foundation have tweaked their terminology a little bit to look at this in a different way. But I think the important bit for me was not the diagram, it's how do we apply that into projects. So I identified a number of systems actions which I thought were important to kind of understand and how they influence the work we do in design. So looping materials through multiple flows of life and end of life and remaking, making sure that things last as long as possible, so holding them in place for extended periods of time through product life extension, looking for different models of a service rather than actually making new things. So how can you get somebody to provide you with a lighting service or other things rather than actually buying lights themselves? How do we actually look at ways of enhancing and repairing our environments, which again, what Jack was talking about in some of his work there. But how do we actually modify things less? So rather than continually applying different processes to materials, how do we actually simplify that to actually make sure that we don't put the impacts into the materials at the beginning, but actually make them more reusable at the end of it as well. So I was exploring some of these functions and how those might apply to various projects, and I'll come back to that in a bit. There are many really useful bits of other work out there. So I'll just highlight bit by Circuit and Andrea Charleston's fantastic work at places like London. Lots of this being explored about new models in the marketplace and how do we actually apply this actively into projects. So what used to be recycling targets is now seeing emerging reuse targets going to be applied into projects shortly. And concepts of urban mining, looking at the ways that we can actually connect suppliers to people who want materials actively through digital systems and databases and platforms. So these are all emerging quite actively in the marketplace, with many people thinking about how they deconstruct buildings now rather than just demolish them and gobble up all that material and make it into hardcore or whatever it might be. So we're actively looking at ways of reusing materials into process. So do look up Circuit and do look up work by London as well. And the other one, which may come up for your work and you have to think quite clearly about, is, well, where do you start a circle, really? So, the linear economy is easy, but where do you begin in a circle? So I actually, with some work through Letty, I kind of suggested, well, I might really rework my original concept and let's say, well, what happens if we do reuse at the beginning of this process? So lots of the conversations of, oh, let's enable the circular economy, but why don't we just do the circular economy right now by reusing? So you can see an emerging conversation around functional reuse of buildings through retrofit first, ways of actually designing with materials that are reused in the first place. Those things are quite more complicated, but they're much more interesting to think about and probably much more impactful in terms of reductions right now in terms of building emissions than other ways of enabling circular economy processes in the future. The missing thing to this, and one explored in the paper, was what is the market? So what we don't have is a functioning market which prioritizes and values some of these material flows currently. So it's really interesting about Part Z and embodied carbon being brought into building regulations, etc. But actually we've got to look at materials in the round and how do we make it more economic and develop broader markets to enable these things to happen automatically, which is what markets really do well. So the interesting piece out of the study was, I thought that there was like a 10-fold factor of value to be leveraged out of taking material, old wood, which was about 50 tons for biomass when I did the paper, and about 500 euros a ton for the input cost of CLT into new buildings. So somewhere between that 500 and that 50 value, there was a market to be made in terms of the economics of reuse of timber overall. So, that needs to be explored, but I think it's a market system that we need to develop, not just a technical one. I think Charlie, who's on here, might recognise some of this data, so apologies, and I hope I've really got it right. So I've tried to burrow into this, but what's really interesting is some of the metrics behind assessments and where those are. So Francesco noted the RICS professional statement, and it has values, which I'm sure they will update in the forthcoming update, but postulating what they thought was the end of life for timber. We have to think about what wood are we talking about here, because there are many and multiple different types of wood that we can think with very different lifespans and very different uses. But they were suggesting that 75% of this went to biomass and about 25% to landfill. But other good data work by Wood Recycling Association, CTI, was saying, well, that data doesn't really seem to fit the reality. So much more of it used for in reuse back into fibre reused back into new products, like particularly panels. Some into landscaping and bedding, quite a substantial into biomass and energy use, but very little into landfill. So we got caught up a number of years ago about, with an argument about will timber in landfill in 1 million years be the new coal, and what were the emissions? So we went down a big rabbit hole about that, but functionally there's not a lot in landfill, so we can probably focus on the other parts of the end of life of timber and what should we do with it. So great work by TDUK and Jane Anderson, again getting a big shout out about her life cycle assessment report, in terms of, she provides some values which I'll show here, which is a slightly update referencing this wood information sheet by TRADA, and slightly different values, which shows again that landfill is really low. Some numbers on material which isn't recovered but actually might go to export and fuel. A significantly different number in terms of panel product and reuse, and more numbers in terms of biomass. And this reflects, and what Charlie was also saying at the beginning, that people are, this fight for fibre, because people are just throwing anything, biomass at anything to try and on their trajectory for net zero carbon. And as Charlie was really saying, must be emphasised, we've got to, and Francesco was saying, we need to find a way of bringing that 20% up to the 56 or more percentage, and actually maintaining that value and the carbon associated with that fibre in use, not just burning it. And that's a really big issue for the industry to face up to. So this is one of the diagrams which I thought I would show, because I think it starts to reveal some of the issues, again, which Francesco was talking about, end of life, and this difference between an early pulse in terms of carbon through manufacture of mainly mineral-based products, and the late pulse that we get in terms of timber-based, bio-based products at their end of life, either theoretically through the carbon accounting methods, or actually technically through the way that we dispose and reprocess materials. So this is data again in that report, which I've delved into to try to put the percentages on there, which I think are consistent with the data in the report. But the really important bit is actually to look at the potential end of life terms that come through these different uses at end of life. So obviously you've got zero when we actually burn anything. That's immediate emissions, which are again adding immediately to global warming and global forcing. We've got some aspects where it's actually quite short, I would have thought, for things like wood, for animal bedding and surfacing, which are all going to end up quite quickly into emissions. And what we have to do is find better routes for the things which get back in, recycled and reused into new panel products, which are much longer and will retain and store this carbon for much longer. So when we're thinking about these end-of-life uses, we actually need to also think, again, as Francesco was emphasising, the term and the temporal issues connected with carbon. and making sure that we retain as much of that, in use, locked up and not emitted as possible. So let's think about that. I wanted to turn to this idea of restorative and generative systems. So you've probably heard about the circular economy, and if you haven't heard of regenerative sustainability, I'm sure you will be over shortly. Not just by me, but many people. It is a broadly popular emerging theme, very much connected to what do we do about this large system challenge, because it's quite evident that just getting towards net zero is not going to be enough. So absolute zero as a strategy popularized by others. What do we do? Because things don't stop in 2050 when we suddenly magically become net zero. We'll have to do much, much more to repair it. And this, I think, to me, connects much more to this whole idea of climate and climate justice and global equity between a developed north and an undeveloped south in terms of what we do and what is appropriate in terms of our approaches. So it's one about responsibility, not just about technical systems. So this is, I'm talking a little bit about this, but like the circular economy, again, there are multiple interpretations of what this means and what we should do about it. So I've given a few kind of screenshots of of material that I've come across, all sort of saying the same thing, that we need to move from depleting degenerative systems to restore and repair and regenerate our systems overall. And this is not just an environmental nature thing. This is also, again, as Jack was talking about, our connectedness to nature, and what do we do about our approach of developing in harmony with nature, not just with using natural systems, is what much of our thinking is today. So this is how I have tried to summarize it and put it to the students who I lecture to at Southampton, which is the simple kind of wedge which we see in multiple ones of moving from degenerative, restorative to regenerative systems. But that intersection point is really along the axis, is to me quite an important one. So if we go back to thinkings from this is 1960s, this is not new. Herman Daly's rules for environmental sustainability. He put 3 really useful rules about what a static sustainable system might look like. I've noted those there. I won't make the terrible fate of actually reading out PowerPoint slides, which is an awful way of presenting. So you can read that yourself or screen grab it. But actually what we also might mean by this regenerative sustainability systems, and here's one by Duplessis, she's an academic from South Africa, talking about what regenerative systems might be like, which is about the way that humans can co-evolve with nature, looking at context. And these are really important topics for, I think, for you to explore in your project as you go forward. What I would say that, it certainly, with regenerative is not what is written in the GLA's whole life carbon tracker. And I've come across this, and this is really disappointing from consultants who have cottoned on to the idea that regenerative systems are really important. They put this really awful kind of explanation of what regenerative design is into a public-facing document. It's awful. So they've kind of noted it, just this overly simplistic idea that it will do something about removing CO2. So if we are going to talk about regenerative systems, let's talk about these emerging ideas of a much broader systems change, and not oversimplify it and undercut it by coming up with these sorts of terminology methods in public-facing documentation. That should be removed, in my view. So what I thought I would do to try to bring this down to a level which is relevant to your design projects. I'll give you an example where, as the Positive Collective, which is friends at Patrick Osborne and Florence Collier, who are an architect and a passive house engineer, we worked together closely on a competition which was Home of 2030, which was for Homes England. We were one of the finalists there, and we've just been shortlisted as a finalist for the UN Habitat Climate Smart Systems Challenge for Bristol. So that's a bit of a mouthful, but we're really happy about trying to push and explore these ideas in practice, and how do we actually connect to that and make and push those into project-based work. So this was our idea for a housing system. I know you're not quite doing a housing system, but some of the ideas hopefully still hold about what you might be able to do. So the first one was homegrown products. So again, our friends up in Scotland are busy trying to, generating homegrown CLT as panel-based products. So shout out to them as well. So how do we look at different ways of affecting the bigger system by using materials which are appropriate from within our resource base? So we were looking at C16 plus as a species-specific grade to the UK. We were looking at lower grade materials and how that might be used in mass products rather than just constantly specifying C24. So what was the use of the materials relevant to the resource base that we had, and how can we start to actually encourage the use of bio-based materials as a way of then incentivizing increasing in a repair of natural systems and improvements in biodiversity. So we were looking at homegrown products and their use as one. Like Robert and others, big fan of off-site manufactured construction as a better way of delivering the buildings that we have to do. But this idea that design for manufacture and assembly is important, but actually it's not the overall systems approach that we really need to be encouraging. So some people would say, well, we need to design for everything, so it's DF Sigma. But actually, if we just follow the design for manufacture and assembly idea about the efficiencies and benefits of off-site construction, we should really be thinking about incorporating aspects for disassembly of buildings right at the beginning as our systems view of an approach. So I just suggested that DFMA plus D should be at least our combined assumption about how we approach and incentivize or utilize off-site methodologies in our approaches. So don't think about just how you can assemble it, but how this might be separated, disassembled and reused at end of first life, not end of life, end of first life, when you're actually designing your systems. We also looked at durability. So if you go back to this idea about extending product life, it's certain that one of the issues to do with timber use is durability. If it's not detailed correctly and not assembled correctly within envelopes, which actually maintain it at a level of moisture which is compatible with its long-term performance. So detailing is really important, and durability, because that actually connects to commerciality and warranty. So people are going to price out or not give insurances and warranties for products which I think are risky. That's just a general way that insurances work. So we need to be really clear and detail appropriately for that. So in your projects, the materials, timber and bio-based materials, will last as long as they are detailed well through it. So have a real look at the detailing and make sure that that is compatible with this idea of buildings with timber lasting their whole life and being certified and warrantable at that. Where that becomes difficult, it was really interesting, and we talked to friends at Passivhaus, because they actually have pre-impregnated CLT as well. So you can find products where it is risky, you can actually reduce that risk by actually looking at ways of preserving either surface treatments or pre-impregnation as alternatives for that. So there are ways that you can actually do this and alter and improve durability while still using bio-based products. But then we have to start thinking about the impact of those preservative treatments and what those do to health, well-being and end of life as well. So we need to be careful about that, but those are also possible. And I thought I would leave you this, because I think I'm getting to the end of it and you're all wanting to go home, is I've got a link here to Kate Rainworth giving a talk about Bill Sharp's 3 horizons principles about repatterning design towards different options. So what we struggle with, and what everybody's struggling with, I think, is to find ways that we can deliver this viable future that we can all imagine, but actually in ways which are consistent and realistic with with what we face currently. So in your work, I would highly encourage you to actually have a look at this. I think it's only about 5 minutes long. It won't take you long to think about, but it's a very good way of thinking around the design challenge that you face and practical ways that you can introduce innovation whilst targeting the future that we're all trying to aim for. So as a way of thinking around some of these big system ideas that you've been thrown at tonight and through all these other great lectures, I would highly recommend that you you go and have a little look at that little video, because it's I find it really, really helpful in my work. So I'll leave you with that, and good luck with your work. I'm sure I'll be delighted to see what you come up with from Tabitha. Thank you.
Thank you so much, Adrian. As you said, we're giving our participants so much knowledge and so much information. I just want to come back before we have time for some questions at the end to reiterate. So these are, and there was a question in the chat about clients. How do you educate your clients? So the clients actually want a building that does no harm, that will enhance the local biodiversity and regenerate the lives of the people that own and use it. They want it to produce more energy than it consumes. I mean, it's to take this knowledge and help them design that. I mean, that is, in a way, that is the challenge. Will this move now? On Thursday, we've got Trimble software. So each team member will be provided with software from Trimble. So come and sign up and join us on there. We couldn't do this without our sponsors, so a huge shout out to them. Some of them are in the audience tonight, and hopefully we will see you again, if not on Thursday, next week, where we'll look at structural timber, making the right choices, and timber buildings designing for importance. Designing for performance, not importance. Forgive my what's names. I'm going to stop sharing and open the floor to questions. And Charlie, would you like to take over?
Yeah, so, okay, so any questions that we've got in the chat? So I'm just thinking what chat, some of the questions we've got in the chat. So Nick Bolton's asked, Adrian, for you this one. As an engineer, how do you go about maximising the opportunities for the reuse of structural wood components?
This is all, every question is going to be prefaced by the great question. Thank you very much for that. I think one way, and there'll be multiple ways for this, but I think one way is actually looking at the way that the wood recyclers specify wood and try to actually make sure that it fits within those categories which maximize the market as it currently stands. So that might, so if you grade material for different reuse at different levels, how do we maintain it and make sure that our processes actually keep it within those areas which are most applicable? What we found in terms of reuse for Passivhaus was that using CLT was a fairly simple one, that we get very large panels of that, and we were using a balloon frame rather than a platform frame approach. So we were coming from pretty big panel elements as it started out with. I know other people's are looking at the way that they make glulam out of old board material, etc. So there's lots of ideas about that. But I think there's a difference between small elemental wood elements and what we're now seeing as a revolution in the design of buildings with mass timber systems. So that's CLT or glulam or laminated veneer lumber. So I don't think there's as much evidence, because we haven't actually got to an end of life of much of that, about what that will be. But where I've seen it thought about, mainly by students actually, who kind of do this for design challenges, is that they, you know, some aspects of imagination that would actually lead to their reuse. But for now, I've focused mainly on the disassembly methodology. So I've been changing connection to detailing quite significantly about understanding how that would be separated or at least easily cut up if necessary to actually maximize the available panel elements in CLT. So that's an area I've been focusing on, and is just the connection detailing, and is whether there's changes to standard methodologies which would enable that into the future.
Great stuff, and I think that ties in with the next question actually from Ali, which is the focus on design for manufacture and assembly over design for deconstruction and material reclamation is surprising. How can DFMA help reduce carbon? Have you got any simple examples? I think you sort of started to answer that, but I think the way you've answered that is what we're looking at for future buildings. But how might they be able to do that in this particular project, maybe?
So I didn't get in a spat on LinkedIn, but I did get into a debate on LinkedIn with somebody over evidencing the benefits of off-site manufacturing in terms of sustainability. So I'm sure we can stick a link to it somewhere, but the esteemed Professor Robert Hairston, myself, and Julia Jones from Mace wrote a paper on off-site manufacturing and its link to sustainability. So Matt, I think I could probably just say reference that perhaps for now. But one of the ways is off-site in terms of the A4, A5 elements of waste reduction is an immediate one. Transportation impacts, an immediate one in terms of reductions of it. Obviously, if you design anything badly, whether it's an in situ or an off-site methodology, it's still designed badly, will still have big impacts. I thought Francesco's kind of overlapping diagrams are really important in that, to show that anything done well is going to be anything better than anything done really badly. And the same goes for off-site or on-site methodology. Jack's got his hand up there.
Great stuff. Jack, you got your hand up there. Do you want to come in there?
Yeah, sorry, it's not to chip in on your realm, Adrian. I was going to answer a question that Tabitha picked up on about the client.
Yeah, I was just coming back to that one.
Okay.
Yeah.
I wasn't sure they were going to.
Yeah. How do we educate clients to be more sustainable? Is it price? Is it legislation? Is it government led? I think it's that question you're just picking up on. Is it, Jack? Yeah. I was just coming to that. There you go.
Fine.
You beat me to it. Go on then.
I mean, from our experience, there's different kinds of clients. And some of our projects are quite small scale, perhaps a little bit more niche. And in that situation, we often find it's our enthusiasm and understanding of sort of systems and nature and design that actually open up a whole new world to that client. And suddenly the project can expand and they get enthusiastic. So a lot of it's about enthusiasm with a sprinkling of expertise. But again, as a designer, we're typically not specialists. Now, when it comes to larger scale projects, clients are often a lot more commercially driven. And a lot of that is outside of your control because they are juggling investors. And those investors are wanting to know that a project is viable and they'll get a return. Now, that is probably more about a cultural shift. Like with a lot of industries, there's a sort of almost like a moral element to it, where people are wanting to move away from some of the slightly more questionable practices into the new world, with better technology, more environmentally conscious technology. So that's a bit of a cultural shift for everyone. But on that point of view, it almost does come down again to people and personalities. So that client who is acting on behalf of investors, if they see quality and expertise and enthusiasm, that can filter back. I know that's quite an idealistic, quite optimistic view, but in our experience, that has happened. And you can actually get clients enthused. And sort of the slightly more background side of things starts to fall into place. And sort of the third element is policy as well, because if you get a local authority that has aspirations, then they will push for us, the team, to push a little harder. And clients, again, will start to see an emerging picture with maybe a planning application for development. they'll see the way the wind is blowing, and it'll filter back to sort of those the bigger picture, if you like. So we like to work on enthusiasm, competence, expertise, and creating a vision that everybody can get behind.
Great stuff.
Charlie, can I just...
Adrian, I was just going to say, do you want to come in on that one as well,
I will
Adrian?
do as well, because, sustainability is a bit of a bashing your head against a wall exercise at times, because you've got to just keep going at it. It can be really, really hard. I didn't put the diagram on it, but I think of it, I'll show it another time, but it's really important to not just be aspirational, but we also kind of understand where the client's realism lies. So there's a difference between what is regulated and required and what is an opportunity. So a lot of the work I've done is by convincing clients that there is value in the opportunity to take them somewhere that they haven't been before. So that's one thing. The second one, from the grubby capitalist point of view, is a real focus in emerging criteria for markets. So the carbon financial disclosure initiatives, where actually there is a requirement to reduce, a requirement to be more resilient, and a value in that, from a market point of view, is a massive game changer. So I think we can also look and support initiatives by others who are changing the broader commercial incentives around being lower carbon, more resilient, and so I think that's to be applauded within the field of things. So there are other initiatives at play, which I think will make the shift easier for everybody.
Great. Thanks, Adrian. Yeah, absolutely. Totally agree. I think there needs to be a higher, lower base, legal base as well, though, which would help. And then that would help with some of those discussions, I think, with your clients as well. So we need to raise that bar from the minimum requirements, personally. But there we go. Just moving on to Rachel. Odd one. This could modified timber such as Accoya or thermopine be used for glulam timber? Anyone want to have a look at that?
Well, Rachel, it depends where you're putting it. So the first thing is, why would you need it? So
absolutely.
The difference is, well, look, if you go back to service class or use class 1 or 2, those are protected or within the thermal envelope. It's only when you get to more exposed elements where you have to think much more carefully and appropriately more carefully about higher grade, either different species or modified materials such as Accoya, to get the levels of durability you want. So if you've got exposed glulam beams outside of the thermal envelope, then yes. And I think people have used it in that way, but I could be wrong.
Yeah.
But there might be other ways of actually dealing with it, or designing without necessarily requiring the timber to perform in that way. So I would design it out first, with all due respect to my mates at Accoya.
I think it's one to, just have a little bit of research on there. I think there has been options before. I know that when you thermally treat timber, it makes it more brittle, so it does reduce the structural integrity. So there may be issues there, depending on where you use it. So just be careful on that one. Okay, moving on then. Sulla, have you worked with, would you recommend the use of Japanese timber structures where solid timber has complicated joints that can be taken down and replaced across its lifetime, or when whole buildings can be disassembled and reassembled elsewhere? Is that something you think that could work for this challenge?
There's a absolutely fantastic book on Japanese wood structures, and I think if you do an apprentice, you get a bag of 1,000 chisels or something to use to do all these. It's phenomenal. In terms of craftsmanship, it's absolutely amazing what they've been able to do with it. And kind of manufacturing methods get nowhere near any of that finessing of the detail in some of those details. So some of the Japanese timber structures are incredibly complicated, but crafts delivered. So it depends on this particular challenge. and what you can think you can do for 1.6 million. And I'm not sure you'd be flying over 7 Japanese carpenters to make it, unfortunately. But I can't remember the name of the book, but it's absolutely fantastic about what you can do. And what it does actually show is an idea about timber design generally, that we shouldn't be mimicking the connection methodologies which have been developed up for other materials. So a lot of what we're doing in design is not designing with timber, but it's designing steel connections into timber systems and thinking that they somehow are right. So I would take the essence of what was developed from that Japanese work, which is actually working with the wood and looking at the way that wood can work with wood to make the connections work. But this is all part of a transition away from, an architecture which is inherently understanding the qualities of the material and working with it, rather than just mimicking historic ones and thinking that the scale, size and form of timber buildings should somehow just be the same as any other old material. It shouldn't necessarily be that way. So we need a new architecture, a new level of detailing. So Salah, it's a very good question, but yeah, I haven't got 1,000 chisels.
I agree. I think there's things that are going to need to be developed over time to try and mimic some of those Japanese joints, maybe some of the simpler ones, because our machining might not be able to match the Japanese craftsmanship, as you say, Adrian. But I think there will be joints that will start to be developed that will start to mimic those. And absolutely, we should try and see if we could use them, if you can keep within the budget. As Adrian says, I think the issue is actually bringing people in. Just moving down. So really, I think Rachel just come back to say she was thinking of as an alternative to preserved glulam. You mentioned, I think just going back, there are options there, and I think it's just a matter of looking at that, Rachel, and the glulam and seeing if you could use thermally modified or Accoya. They do glue well, so it's just again, it comes down to budget, because they will be more expensive. There will be issues there with cost if you've done the whole structure in that. But if you could design it in a way that you could just use certain bits, maybe the exposed areas, maybe that could be glulam or that could be Accoya or thermally modified. Whether that would work, that's one maybe for Adrian. That's maybe something to look at.
Robert's usefully referenced his replacement of concrete foundations using Accoya.
There we go. I've just seen that. Yeah.
And the Maggie Centre shows a beautiful. By DRMM, shows an absolutely fantastic use of Accoya in the cladding as well. That's absolutely gorgeous.
Yeah. I think one for you, probably coming on to our last one because we're over time. Adrian, to further to Nick's question, are we likely to see longer continuous laminated timber structural sections to maximise flexibility for reuse, assuming compression loads perpendicular to the grain, acoustic, hygrothermal issues? It keeps jumping around because it's adding new questions. Hygrothermal issues are solved. If you see that one.
So at another time, not for today, and when it's completed, we'll probably talk about Charlton Workstack, which is a project again by Architects DRMM. It's I consult still back to Arup on it. It's got, these are monster panels, they're fantastic. 19.2 meter long CLT floor panels, and they are 3.5 meter wide by 10 meter long wall panels in one section. They're monsters. But all put in place by Parkinson's, supplied by B&K. It's fantastic. So this idea that we have to have teeny lengths of timber in mass timber is completely wrong. Absolutely. So we can actually do it. The difficulty, though, I think, is that how does this actually enable reuse? So it'll be getting them out again. They are in one piece, and that might help. But it's going to be. But long sections are enabled through finger jointing and an amazing glue, which is why mass timber is so great.
I think the only limit is actually getting it to site is the biggest barrier. It's obviously got to somehow fit on a lorry at some point, or unless you manufacture it on site. But then it's how do you move it elsewhere? It comes back to what you're saying. If you deconstruct it and want to move it, that big section, how do you move it somewhere else is the issue.
So 19 meters is long, right?
Yeah.
That's a big panel. And I think the cost actually, to be upfront about, the cost is actually in the ferry and the number of bays you need on a ferry
to
get an overlength thing. So a really great book by War Thistleton and others looking at off-site manufactured systems and the limits of that. So if you stick within conventional trucking limits of panels, and you don't get any of those cost benefits. So if you can work within that, we just couldn't in this particular project for various reasons, and came up with
stuff.
Absolutely monster panels.
I think, okay, last couple of questions here. I think just a couple of clarifications. To be clear, there are connectors developed that allow deconstruction, such as the Sherpa type connections, and Rother Blast, I think, also do them. And there's a number of other manufacturers, you know, there's the BBC, you know, there's lots of different manufacturers out there that make deep mounted connections. I think Robert's also just mentioned that, remember, stainless steel, he's saying nails, maybe screws, removable sections if you're using a coir because of the acetylated treatment. One question from Ellen, slightly weird question. Is there, she's saying, that's her words, not mine, is there a prospect of genetically modified timber like GMO food in our food chains at the moment, but for higher performance in construction?
This has come up. It's not that weird, by the way. It's not a weird question, because what somebody has talked about is the impact of the connections on elements, and that's often the controlling aspect of timber design. It's not the element itself, it's the connection of the element to another element. And there was a conversation with Michael Ramage a number of years ago when he was doing all his wood for the tree stuff about, well, how could we grow weird shaped wood which actually had, you know, something bigger at the end of it, or different properties at the end of a material where we actually needed it. So it has come up. So Ellen, well, not that
it probably will happen at some point in the future, is what we're saying. I think that's the good point today. I think there was a couple of just little bits there, just as in the chat. I'm sure Tabitha picked them up and send them around about the size of panels it could be making, and that we've got a coir speaking on the 1st of March. But I think we'll have to probably leave it there, I think, Tabitha, because we're well over our time at the moment, and I know my dinner's probably just sitting on the table now, ready to go. So thanks very much. Tabitha, do you want to say the closing remarks, final few words? But from me, thanks to everyone for attending, and thanks to our speakers. Really appreciate your time tonight. I know it's you know, you're after time, and so Jack and Adrian, and obviously Francesco, who's not here anymore, really appreciate your time tonight. And thanks very much for your really insightful talks there. So Tabitha, back to you.